Okay, I hope I'm audible to all the students who are attending this lecture. We continue with a new chapter. We start with a new chapter today in class 12th mathematics. This is called as integrals. One of the most important chapters in class 12th maths, from where you will get questions for sure. Okay, so let's first write the definition of integrals. If there is a function capital F such that the derivative of capital F of x is equal to small f of x for all x belonging to the interval I, then for any arbitrary real number, then for any arbitrary real number C called the constant of integration, d by dx of f of x plus c will be equal to f of x for all x belonging to the interval I. So I can say thus capital F function, thus capital F of x plus c, where c is the constant of integration belonging to set of all real numbers, denotes a family of antiderivatives. Antiderivatives of the function f. So let us discuss this. Suppose there is a function capital F such that if you differentiate the function capital F, you get small f of x. You are differentiating the function capital F of x with respect to x and you get small f of x. Then capital F of x is called the antiderivative or the integral of the function f. So I can say capital this f of x plus c is called the antiderivative or the integral of the function f. So I once again repeat, if you have a function capital F of x and if you differentiate capital F of x with respect to x and you get small f of x, then capital F of x plus c, where c is called the constant of integration, is called the antiderivative or the integral of the function small f. So I can write symbolically integral f of x dx is equal to capital F of x plus c. So I hope all students have understood this. The notation we use is as follows. Okay. Y is equal to, so given dy by dx equal to f of x, we can write y as integral f of x into dx, where small f of x is called the integrand, small f of x is called the integrand, x is called the variable of integration, x is called the variable of integration, c is called, in the entire integral lecture, c will be called the constant of integration, and this will denote the sign of integration. So I hope all students have understood the lecture till now. So if I quickly revise, there are two functions, small f of x, capital F of x. If you integrate small f of x, you will get capital F of x. If you differentiate capital F of x, you will get small f of x. Very simple. You can see it on the screen. If you differentiate capital F of x, you will get small f of x. And if you integrate small f of x, you will get capital F of x. And C denotes the constant of integration. So I am writing it. So what do we learn? So when we integrate f of x, we get capital F of x plus c. That is, if I integrate f of x, dx denotes that x is the variable of integration. When I write dx, dx means that x is the variable of integration. So when I integrate f of x, I get capital F of x plus c. And when we differentiate capital F of x, we get small f of x. That is, d by dx of capital F of x plus c gives us back the small f of x. So integrating small fx gives us capital F of x plus c, and differentiating capital F of x plus c gives us back the function small f of x. So I can say that integration and differentiation are inverses of each other. The process of differentiation and integration are inverses of each other. Because when you integrate small f of x, you get capital F of x plus c. When you differentiate capital F of x plus c, you get back the function small f of x. So they are the process of differentiation and integration are inverses of each other. Now let's do some formulae. So what we are doing today, list of formulas for indefinite integrals. Now, indefinite integrals are those integrals which are not defined in any one particular interval. I repeat, indefinite integrals are those integrals which are not defined in any one particular interval. If you define the integral in any one particular interval, it's called a definite integral, which we'll be doing in the later part of the lectures. Okay, so first let's look at the formula. So formula number 1, integral of x to the power n dx is x to the power n plus 1 upon n plus 1 plus c. You will always have c in indefinite integrals, where c is the constant of integration. Always remember, in indefinite integrals you will always have c, which is the constant of integration. And this is well defined if n is not equal to minus 1. Because if n is equal to minus 1, the denominator becomes 0. So the function becomes not defined. Second formula, integral of dx is equal to x plus c, or I can say integral of 1 times dx. Integral of 1 with respect to dx will be x plus c. Third formula, let's look at the trigonometric formulas. Integral of cos x dx will be sin x plus c. Fourth formula, integral of sin x dx is minus cos x plus c. Fifth formula, integral of sec square x dx is tan x plus c. Integral cosec square x dx is minus cot x plus c. Seventh formula, integral sec x tan x dx is equal to sec x plus c. Integral cosec x cot x dx is equal to minus cosec x plus c. Then integral of dx upon under root 1 minus x square is equal to sine inverse x plus c. 10th formula, integral of dx upon under root 1 minus x square. Let me verify this. Our 9th formula is correct or not? Yeah, integral dx upon under root 1 minus x square is also equal to minus cos inverse x plus c. Okay. Then 11th formula, integral of dx upon 1 plus x square is tan inverse x plus c. I can also write integral dx upon 1 plus x square is minus cot inverse x plus c. Okay. And then the 13th formula, integral dx upon x times under root x square minus 1 is equal to sec inverse x plus c. 14th formula, integral dx upon x times under root x square minus 1, I can also write as minus cosec inverse x plus c. 15th formula, integral ex dx is e to the power x plus c. Integral 1 upon x dx is log of mod x plus c. And the last formula, integral a to the power x dx is a to the power x by log a plus c. So all students should remember these 17 formulae. Write them on an A4 size sheet of paper and stick them in your study boards so that every day you go through these formulae again and again. Now you can see when you integrate the left hand side, you will get the right hand side. And try at home. You differentiate the right hand side, you will get back the left hand side. So see, in these formulae, if you differentiate the right hand side, you will get back the left hand side. For example, suppose I differentiate this. What will be the differentiation of this? N plus 1 into x to the power n plus 1 minus 1, which is n upon n plus 1. C ka derivative is 0 because c is a constant. What do I get? X to the power n. Similarly, you can see for every other part. You can see for every other part. If you differentiate the right hand sides, you will get the left hand side. And if you integrate the left hand side, you will get the right hand side. Very simple. So just as all students have learned up the formulas for differentiation, all students are requested to today itself learn the formula for integration. So I repeat, x to the power n ka integral is x to the power n plus 1 upon n plus 1 plus c. Integral of dx will be x plus c. Integral of cos x dx is sin x plus c. Integral of sin x dx is minus cos x plus c. Integral of sec square x dx is tan x plus c. Integral of cosec square x dx is minus cot x plus c. Integral of sec x tan x dx is sec x plus c. Integral of cosec x cot x dx is minus cosec x plus c. Integral of dx upon under root 1 minus x square is sin inverse x plus c. Similarly, the same thing will also give me minus cos inverse x plus c. Moving on to the formulas on the right. integral of dx upon 1 plus x square is tan inverse x plus c. The same thing will also give us minus cot inverse x plus c. Similarly, integral dx upon x times under root x square minus 1 is sec inverse x plus c. And the same thing will also give us minus cosec inverse x plus c. Integral ex dx will be ex plus c. Integral 1 upon x dx will be log of mod x plus c. And integral ax dx will be ax by log a plus c. So I hope all students are clear with this. Moving forward, let us now do properties of indefinite integrals. So let's look at the properties. So property number 1. If I differentiate the integral of f of x dx, I will get back the function itself. That means if I integrate f of x dx and then I differentiate it back, I will get the function itself. Okay. And if I integrate the differentiation of the function, I will get f of x plus c. What does this mean? This means if we integrate f of x and then differentiate it with respect to x, we get back f of x. And this means if we differentiate f of x with respect to x and then integrate it, we get back f of x plus c, which is the constant of integration. So every mathematical sentence you should be able to understand it logically also. If I integrate a function and then differentiate it, I will get back the function itself. And if I differentiate a function and then integrate it, I will get back the function plus the constant of integration. Okay, so second property, two indefinite integrals with the same derivative lead to the same family of curves, and they are equivalent. Okay, so two indefinite integrals which have the same derivative will lead to the same family of curves and they are equivalent. So let's take the example. So suppose f and g are two functions. Suppose f and g are two functions such that if you differentiate the integral of f of x dx, it is exactly equal to the derivative of the integral of the g function. So I can write it like this. This implies d by dx of integral fx dx minus d by dx of integral gx dx is equal to 0. I can take d by dx common. This is what I get. So I can say if my derivative of this is equal to 0, what does this mean? This means that this whole term is nothing but a constant, because all of us know that derivative of a constant is 0. So I can say that integral fx dx is equal to integral gx dx plus c. So they are equivalent. So therefore, integral fx dx and integral gx dx are equivalent. So I hope all students have understood the second property. I am repeating the second property again for all the students. Two indefinite integrals with the same derivative. Same derivative means integral of f of x dx car derivative and integral of gx dx car derivative. If these two are equal, then they lead to the same family of curves. And we have even shown it. You can see I can bring everything to the left hand side. This is what I get. I can take d by dx common. So d by dx of the whole term in the bracket equal to 0 means what? All of us know derivative of a constant is 0. It means the term in the bracket is nothing but the constant. It means integral fx dx is nothing but integral gx dx plus c. It means the two integrals are equivalent and they represent the same family of curves. So I can say, therefore, the family of curves, one family of curves is integral f of x dx plus c1, where c1 belongs to real number, and another family of curves will be integral gx dx plus c2, where c2 also belongs to real numbers, are equivalent. The two family of curves are equivalent. So property 1 says, I'm revising it. Property 1 says, if you integrate a function and then differentiate it, you will get back the function itself. Within property 1, the second part says, if you differentiate a function and then integrate it, you will get back the function plus the constant of integration. The second property says, if two indefinite integrals have the same derivative. That means if integral fx dx car derivative and integral gx dx car derivative are equal, then the two will have the same family of curves, which we have proved. You can see the proof on the screens. So integral fx dx has come out to be exactly equal to integral gx dx plus c. That means the two family of curves are exactly equivalent. So the family of curves integral f of x dx plus c1, where c1 belongs to real numbers, it's a constant, and integral gx dx plus c2, where c2 also belongs to real numbers and is a constant, they are all equivalent. Moving on to the third property, integral of f of x plus g of x dx is equal to integral f of x dx plus integral g of x dx. That means integral of the sum is the sum of integrals. Fourth property, for any real number k, integral of k times f of x dx is equal to k times integral f of x dx. That means for any real number k which is a constant will always come out of the integration sign. So I can write integral of k times f of x dx as k times integral f of x dx, where k is a constant and a real number. Okay. Fifth property, so I can say using properties 3 and 4, using the properties 3 and 4, we can generalize and write integral k1 into f of x1 plus k2 into f of x2 plus dot kn into f of xn. I can write as dx is equal to k1 into integral. Guys, this is small mistake we have made. Let me correct it. This is function 1, function 2, function n. So k1 into f1x plus k2 into f2x plus dot kn into fnx ka integral is k1 into integral f1x dx plus k2 into integral f2x dx plus kn into integral f of xn dx. So property 5 is something which we learn from properties 3 and 4. If I generalize using properties 3 and 4, I can say that integral of k1 into f1x plus k2 into f2x plus dot kn into fnx dx is k1 into integral f1x dx plus k2 into integral f2x dx plus dot kn into integral fxn fnx dx. Let me correct it. Fnx dx, where k1, k2, dot kn all belong to set of all real numbers. So I hope all students are clear with the properties of integration. Okay, now let us do some examples of this. So solved examples. So let's look at example 1. So find integral of cos 2x dx. Now from the chart which all the students have made, the formula which I have given to you, so recall that integral of cos x dx is sin x plus c. Therefore, integral of cos 2x dx will be sin 2x. In differentiation, you used to multiply by 2. In integration, you will divide by 2. You will just do the reverse. When we used to differentiate cos 2x, what did we used to say? Differentiation of cos 2x is minus sin 2x into 2x ka derivative is 2. So we used to get minus 2 sin 2x. But now when we are integrating cos 2x, we know that cos x ka integral is sin x plus c. So cos 2x ka integral will be sin 2x. In differentiation, you multiply by 2, but in integration, you will divide by 2. So divide by 2 plus c. So this is my answer, where c is the constant of integration. Similarly, example 2, find integral 3x square plus 4x cube dx. So this will be, recall that integral of x to the power n dx is x to the power n plus 1 upon n plus 1 plus c. So applying this, integral 3x square plus 4x cube dx we can write as 3 times integral x square dx plus 4 times integral x cube dx. The constants come out. X square ka integral is x cube by 3 plus x cube ka integral is x to the power 3 plus 1, 4 by 4 plus c. So this will be x cube plus x4 plus c. This is my answer. So I hope all students are clear with this. Example 3. All what we are using is the table which I have given you, the formula table. So find integral 1 upon x dx. So solution, we have just done integral 1 upon x dx is nothing but log of mod x plus c. Okay. Let's look at example 4. Find integral of x cube minus 1 upon x square dx. So how we solve this? I can write, this is my question, I can write it, I can separate it. I can write it like this. X cube by x square is x minus 1 upon x square is x to the power minus 2 dx, which will be integral x dx minus integral x to the power minus 2 dx. Integration of x will be x to the power 1 plus 1 upon 1 plus 1 minus x to the power minus 2 plus 1, which is minus 1 upon minus 2 plus 1, which is minus 1 plus c. So this will be x square by 2 plus 1 upon x plus c. So this is my answer. X square by 2 plus 1 upon x plus c. Let's do example 5. Find integral x to the power 2 by 3 plus 1 times dx. So this is the question. I can write it like this. Now x to the power 2 by 3 का integral will be x to the power 2 by 3 plus 1 upon 2 by 3 plus 1 का integral is x plus c. This will be x to the power 5 by 3 divided by 5 by 3 plus x plus c, which is 3 by 5 x to the power 5 by 3 plus x plus c. This is my final answer. Let's do another example. Find integral x to the power 3 by 2 plus 2 ex minus 1 upon x dx. I can write it like this: integral x to the power 3 by 2 dx plus 2 times integral e to the power x dx minus integral 1 upon x dx. Now x to the power 3 by 2 ka integral will be this, plus 2 times e to the power x ka integral is e to the power x minus, we have just done that integral of 1 upon x dx is log of mod x plus c. X to the power 5 by 2 upon, this will be 2 by 5 plus 2 ex minus log mod x plus c. So this will be my answer. I hope all students are clear. Any doubts, you can unmute your mics and ask. So now, example 7. Find integral sin x plus cos x dx. Now we have trigonometric based questions. This I can write integral sin x dx plus integral cos x dx. From the table I have given you, sin x ka integral is minus cos x ka integral is sin x plus c. This is my answer. Example 8. Find the integral of cosec x into cosec x plus cot x dx. So first I can open up the brackets, cosec square x plus cosec x cot x dx. This will be integral cosec square x dx plus integral cosec x cot x dx. Now from the table I have given you, cosec square x ka integral is minus cot x and integral of cosec x cot x is minus cosec x plus c. So my answer will be minus cot x minus cosec x plus c, where c denotes the constant of integration. Okay. Next example, example 9. Find integral 1 minus sin x upon cos square x dx. So this I can write as 1 upon cos square x minus sin x upon cos square x. I can separate it. 1 upon cos square x is sec square x minus sin x by cos x is tan x into 1 upon cos x is sec x. Sin x upon cos square x I can write as sin x by cos x into 1 upon cos x. Now sin x by cos x is tan x and 1 upon cos x is sec x. This I can write integral sec square x dx minus integral sec x tan x dx. Now from the table I have given you, you can check that sec square x ka integral is tan x and sec x tan x ka integral is sec x plus c. This is my answer. And the last question for the day, after which we stop, example 10. Find the antiderivative. Find the antiderivative of the function f defined by f of x is equal to 4x cube minus 6, where initially my capital F of 0 is 3. So guys, what are we given? We are given small f of x function and we are given that the value of capital F at 0 is equal to 3. So first of all, how do we find the antiderivative? So antiderivative of f is given by integral f of x dx. What do I call the antiderivative? Capital F of x, right? Antiderivative is called capital F of x. Is nothing but integral small f of x is 4x cube minus 6 dx, which will be integral 4x cube dx minus integral 6 dx, which I can write as 4 times integral x cube dx minus 6 times integral dx. Constants come out. Now x cube ka integration is x to the power 3 plus 1 upon 3 plus 1 minus 6 into integral of dx is x plus c. This is my capital F of x. Capital F of x is 4x4 by 4 minus 6x plus c. 4 and 4 cancel. And we are given that f of 0 is 3. That means if I put f of 0 as 3, let me put x as 0. So 0 minus 6 into 0 plus c is equal to 3, which implies my c is equal to 3. Therefore, my antiderivative capital F of x is x4 minus 6x plus my value of c is nothing but 3. So this is my final answer. So I again repeat, in example 10, they were asking us to find the antiderivative of f. Now antiderivative of small f is nothing but capital F of x. How do we find capital F of x? Integrate small f of x. You know how to do the integration. This is what we get. Now in the question, they are giving us that f of 0 is 3. That means if you put x as 0, f of x is 3. So what do we get the value of c as 3? So my function antiderivative is nothing but f of x is equal to x4 minus 6x plus 3. So I hope all students have understood the lecture today. I hope all students have enjoyed the integration which we have done today. Now what I'm doing is giving some homework regarding exercise 7.1. So homework, exercise 7.1 of NCERT. all students will do practice question 2. Okay, question 5, do question 2, do question 4, do question 8, do question 9. Just do these 4 questions for homework. Questions 2, 4, 8 and 9 are for homework. The remaining questions will be discussed in the next lecture. So questions 2, 4, 8 and 9 are for homework. So this is where I stop in the lecture today. Any doubt, you can unmute your mic and ask, or you can call me, or you can mail me your doubts at divineschooloфeconomics@gmail.com. So this is where I stop.